and I request all of you to mute your mic. Good morning to all of you. So today I'm going to take up the topic mathematical modeling. Mathematical modeling is an attempt to study some part or form of the real life situation, real life problems in mathematical terms. So in this we are using mathematical model, and some confusion is there with respect to mathematical model, is that mathematical modeling and mathematical model. So mathematical model is a mathematical relation that describes some real life situation. For example, you have solved some problems with respect to simple interest using the formula for finding it. The formula or equation is a relation between the interest and the other three quantities that are related to it: the principal, the rate of interest, and the time period. This formula is an example of a mathematical model. So mathematical model is a mathematical relation that describes some real life situation. If we are using uh, that formula means that simple interest formula, if by putting directly P, R, T and using that formula, then that will not come under mathematical modeling. So we have to create some real life situation to use this model, then only that will become a modeling. Okay, so now let us move towards the process of translation of a uh, problem real life problem into a mathematical form can give a better representation and solution of certain problems. So the process of this translation is called mathematical modeling. In mathematical modeling, we will take a real life problem and we'll write it as an equivalent mathematical problem. Then we then solve the mathematical problems and interpret its solution in terms of real world problem. After this, we'll see to what extent the solution is valid in the context of the real world problem. And I will show you some of the examples where mathematical modeling is of great importance. So, for example, finding the width and depth of a river at an unreachable place. So, we cannot directly measure the width of the river or depth, but we'll use mathematical modeling to find out the width and depth of the river. Like that, estimating the mass of Earth and other planets, estimating the distance between Earth and any other planets, predicting the population of a city after 10 years, estimating the number of leaves in a tree, estimating the number of fishes in a pond, estimating the temperature on the sun's surface. These are all real life estimations, and that can be done by using mathematical modeling. So there are a very large number of advantages of mathematical modeling. So let us move towards the next section, that is advantages of mathematical modeling. The first one is model exactly represent the real life problem situations. Models help managers to take decision faster and more accurately. And the third one is that they typically offer convenience and cost advantages over other means of obtaining the required information on reality. And the large and complex problems can be solved with ease. Like we have seen some of the examples which are very large and complex problems, and that can be solved with the help of mathematical modeling. And the last one is models act as a communicators to others by providing information and impact in changing conditions. Now we'll move towards how many different types of models we are using in our day-to-day life or in teaching. So our next section is different types of models. So the first model is physical model. A physical model, most commonly referred to simply as a model, but in this context distinguished from a conceptual model. For example, while describing a solar system, we cannot show the solar system, the real solar system, to the students. So for that we use physical model. So such type of models will come over here. Even engineers, even scientists also use physical models. And the next one is conceptual models. A conceptual model is a representation of a system that uses concepts and ideas to form some said representation. Conceptual modeling is used across many fields, ranging from the sciences to socio-economics to software development. And the third one is scientific models. The scientific models is a physical and or mathematical and or conceptual representation of a system of ideas, events or processes. Scientific models are used to explain and predict the behavior of real objects or systems, and are used in a variety of scientific disciplines ranging from physics and chemistry to ecology and the earth sciences. So these are mainly widely used by our great scientists. And now let us move toward the next one, the learning models. Learning models are any framework that defines the mechanism of learning. Basically, a learning model is any form of learning new skills or information. These models have subcategories that further divided into various learning styles that we will see in the coming slides. Now we'll move toward the next type, digital models. Digital modeling is the process of creating a computer model of an object that exactly replicates the form of the objects. I will take up in the next section of today's session the digital models. I will show some of the digital models how to use in the mathematical modeling. Now the next one is pedagogical model. Pedagogical models are those models which teachers sometimes provides to students so that they better understand some mathematical concepts. The pedagogical model describes what effective teachers do in their classrooms to engage students in intellectually challenging work. And I will take up a brief of pedagogical models. In these five domains are also there. I will take up in the next sections. Next one is mental models. Mental models are how we understand the models. Not only do they shape what we think and how we understand, but they shape the connection and opportunities that we see. Mental models are how we simply complexity, why we consider something more relevant than others, and how we reason. A mental model is simply a representation of how something works. We cannot keep all the details of the world in our brains. So we use some models to simplify the complex into understandable and organizable chunks. And some games are also used as a mental models. And now we'll move towards the next model is modeling phenomena. We often understand real world phenomena through these models. To be able to do this, we need to be aware of the basics and the operation of modeling and the methods of its application. Modeling should be used not only for understanding but also for predicting real world phenomena. And the last one is modeling real world. And nowadays we have a lot of problems in real world, and that can be done in that also. We can do the modeling also, like population growth, disease propagation, traffic flows, and nowadays COVID-19 is also there. It is very popular. That is a big real world problem that also we can take up, and we can do the mathematical modeling. Earthquake impacts, climate, and energy prediction models are widely used to plan for sustainable use of resources and management of the natural and built environment. Using real world examples drawn from physics, chemistry, biology, and earth sciences, this subject introduced students to framing these sometimes complex systems firstly as conceptual models, then as logical and mathematical models. So these logical and mathematical models are then brought to life using some tools such as software representations and graphical representations and simulations for the system of interest. Now we'll move towards the another section, one very real world problem that we are facing nowadays, that's COVID-19. So COVID-19 modeling example, this is a real world problem. And if you want to understand the nature of COVID-19 through mathematical model, we can choose any particular issues like We can choose this migrant workers problem. So there were so many issues came up which we are facing, like we saw migrant workers going back to their native places, and there was no transport available at that time, so that it came out as a big problem for our country. And then there was inflation in like almost all the basic essential things. Prices have hiked, so these things are affected our day to day life. So we can also study national budget. Even we can also study our daily budget through mathematical modeling. And demographic nature of COVID-19 also we can study with the help of some graphical representation like age, gender, race, culture, country, states, economic classes. So what we will do, first we will identify the problem, then we will define, then we'll collect the observation, then we'll do the model. So we'll represent model means we'll represent it in a graph or some in other format. So this is one website. The website address is www.cdc.go gov. I will show the website also. This is the website. Here, so many. This is the particular COVID-19 website mathematical modeling. So mathematical modeling helps CDC. CDC means Centers for Disease Control and Prevention, and partners respond to COVID-19 pandemic by informing decisions about pandemic planning, resource allocation, and implementation of social distancing measures and other interventions by using mathematical modeling. So this is a real world problem and real world situations, a situation that is COVID-19. In this, we can show some graph also. This, for example, I took uh, this is from 1st December 2020, top 5 states with most new cases reported, and it is represented by a graph. And top 5 states with most death reported. Like that, we can collect the data and we can do the modeling. This is the data taken on as on 1st December 2020. Most top 5 states with most recoveries reported, and top 5 countries reporting highest COVID-19 cases. So these are data are readily available in the internet that we can take up and we can do the modeling. Okay, so now we'll move towards the process of mathematical modeling. What steps we have to use while doing the mathematical modeling? So the first step is the understanding the problem. We'll take the real life problem and we'll understand the problem. After that, what we will do, we will define the real problem, and if working in a team, then we will discuss the issues that you wish to understand, and simply by making assumptions and ignoring certain factors so that the problem is manageable. After that, we'll go to the step number 2, that mathematical descriptions, describe the problems in mathematical terms. That is mathematical descriptions and formulation part, it is there. We'll describe in mathematical terms the different aspects of the problem, that real life problem. Some ways to describe the features mathematically will include define variables, like writing equations or inequalities, or will gather data and organize into table, or will make some graphs, and will calculate some probabilities, like that. Some mathematical formulation will do in this step, and the next step is will solve the problem. Okay, so this is the step number 3, solving the mathematical problem. The simplified mathematical problem which develop in step number 2 is then solved using some mathematical techniques or formula. Now the step number 4 will interpret the solution in real life situation. The solution obtained in the previous step, that is step number 3, is now looked at in the context of the real life situation that we had started with the step number 1. After that, we'll validate the model. So the next step is the validating the model. Does the solution capture the real life situation? If yes, then our model is suitable. If no, then we have to back to again describing some assumption. We'll back to the step number 2. Okay, so we go back to the original situation and see if the results of the mathematical work make sense. If so, we use the model until new information becomes available or assumptions change. I will explain with the help of 2 examples. And sometimes because of the simplification assumptions we make, or we may lose essential aspects of the real problem while giving it mathematical description. In such cases, the solution could very often be off the mark and not make sense in the real situation. If this happen, we reconsider the assumption. We will change the assumption made in step number 1 and revise them to be more realistic, possibly by including some factors which were not considered earlier. So we'll see one example, the estimation of fishes in a lake. So we'll take up the problem, and the first step is that understanding the problem. So suppose our problem is estimate the number of fishes in a lake. It is not possible, definitely it is not possible to catch each of these fishes and count them. So what we will do, we could possibly capture a sample, and from it will it try and estimate the total number of fishes. Okay, so this is the a small pond, and now we are going to move toward the step number 2. Step number 1, we understand the problem, what we have to do. Okay, now step number 2, what we will do, we will take up a sample of some 20 fishes from the lake, and what we will do, we will mark them, all the 20 fishes we will mark them, and then we will release them in the same lake so as to mix with the remaining fishes. Now we then take another sample, say 50 fishes from the mixed population, and see how many are marked. So we gather our data and analyze it. So this is the second step. Now the third step is the solving the mathematical problem. This is the third step. We got 5, suppose we got 5 marked fish. Okay, suppose we got 5 marked fish in step number 2. So the ratio of the 5 out of 50 is the 1 upon 10 of the whole population is marked. So if this is typically of the whole population, then 1 by 10 of the whole population will be equals to 20 fishes, which we marked in the step number 2. So that means whole population will be equals to 20 into 10, that is 200. So we solved the solution here. Now we'll move toward the step number 4, that is interpreting the solution. The solution obtained in the step number 3 is now looked at in the context of the real life situation that we had started with the step number 1. For instance, our solution in the problem in step number 3 gives us the population of fishes as 200. And now step number 5 will validating the last step is validating the model. Now we'll go back to the original situation and see if the results of the mathematical work make sense. If so, we use the model until new as information becomes available or assumption changes. For example, in the second step we took 50 samples, and we got I have taken as example 5 we got marked fish. Suppose if we are not getting any marked fish, so what we will do, you can unmute and you can give the answer. What you will do if we are not getting any marked fish while taking 50 samples in the second step? I am audible to everyone?
So we can change the assumption.
Yes, sir, you are audible.
Yeah. So
Yes.
we can take another sample. We can take another sample of 40 fishes
Yes,
or
sir.
50 fishes. Okay, so in that way we can repeat our this process until new information becomes available, or until the result of the mathematical work make sense. Now we'll move towards the second example, simple interest. It's a very small topic, and I'm going to take one problem, and the first step is understanding the problem. We'll understand what we have to do and what is given. Suppose Ajay has invested rupees 15,000 at 8% simple interest per year. With the return from the investment, he wants to buy a washing machine that cost rupees 19,000. For what period should he invest rupees 15,000 so that he has enough money to buy a washing machine? So 19,000 is the final. So how much extra he has to pay? 4,000.
4,000.
Okay. So here
4,000.
we will understand the problem that, okay sir, thank you. Here we know that the principal and the rate of interest is given, and the interest is amount which Ajay needs in addition to pay rupees 15,000 to buy the washing machine. So we have to find the number of years. So next we will move towards mathematical description part, the third step number 2. Now we'll use the formula as our mathematical model, that is I is equals to P into R into T upon 100. So where P is principal amount and principal, and T is number of years, and R is rate of interest, and I is the simple interest. Okay, so here the principal amount is given rupees 15,000, and the money required by Ajay, this is Ajay, money required by Ajay for buying a washing machine is rupees 19,000. So the interest to be earned is 19,000 minus 15,000, that is equals to 4,000. Now we have the formula that I is equals to P into R into T upon 100. So we'll substitute the value of I, P, R in this formula. Okay. So after substituting, we'll form an equation. So we'll get I is equals to, if you simplify this, we'll get I is equals to 1,200 into T. Now this gives the relationship between the number of years and interest. If rupees 15,000 is invested at an annual interest rate of 8%. Now we have to find the period in which interest earned is rupees 4,000. So we'll put the value of T as 4,000 in this formula. So we'll get the final equation, 4,000 is equals to 1,200 into N. Okay, we took T, this is T. So now we'll move towards the step number 3. We'll solve the mathematical problem. So T is equals to 4,000 upon 1,200. So if you solve this, we'll get 3 1 by 3 mixed fraction. Please, I request everyone to mute your mic. Now we'll move towards step number 4. We'll interpret the solution. 3 1 by 3, 1 by 3, 1/3 of a year. 1/3 of a year is 4 months. So that means this is Ajay. That means Ajay can buy a washing machine after 3 years and 4 months. So will now this is possible in real life situation. Now we go back to the original situation and see if the results of the mathematical work make sense. If so, we use the model until new information becomes available or assumption changes. So now we'll move towards the next part. Next part is a very important part, that is the curricular expectation. So I have taken a snapshot of this part to just like understand similarity which our curricular expectation kind of noted, and like the similarity what we have in mathematical modeling. For example, we'll start with the first one. mathematization. The teaching of mathematics should enhance children's ability to think and reason, to visualize and handle abstractions, to formulate and solve problems. Access to quality mathematics education is the right of every child. So, this first one is connected with our mathematical modeling, and the second one, mathematical vocabulary. Knowledge of math vocabulary is an essential component of learning mathematics. In order to communicate math thinking clearly, students need to learn and use appropriate vocabulary. Some strategies we can also use for this math vocabulary. We can start with what they know and use student friendly some definitions, explicitly teach new math words, and give students multiple exposures to math words. We can set up a classroom math word wall and individual math word banks, and we can use mathematics journal also. So now we'll move toward the third one, that is consolidation and generalization of the concepts learned so far. So by looking the pattern, first we have to represent the data in a more meaningful way. For example, in a chart form, in graph form, and that we have already seen that COVID-19 data was also represented in graph form, how the number of cases increases at one point. It will reach the peak and then slowly it will go down, because now people will also develop the immunity, and like there are people who are defending for the case of hard immunity. If the hard immunity develops, then cases will reduce. All these will more clear when we are representing in a graphical nature. And the next one is understanding and proving mathematical statements. For example, in a factor theorem, you are given a polynomial p of x, and are told that p of a is equals to 0. So you have to use this to show that x minus a is a factor of p of x. Similarly, for converse of factor theorem, you are given that x minus a is a factor of p of x, and you have to use this hypothesis to prove that p of a is equals to 0. And the next one is addressing problems that come from the other domains, such as social, such as science and social sciences. So this is the problem with our curriculum, that when we are dealing with some topics, sometimes we are fixated with our maths concepts only. For example, if we are teaching algebra, then we will fix ourselves with algebra only. Uh, okay, so and not connect with the other problems which are present in science, social science. For example, equation of motion. If we are talking about equation of motion, the linear equation in first equation of motion is there, that is v is equals to u plus at, and quadratic equation in the second equation of motion, s is equals to ut plus half at square. Like that we can take up the we can connect with the science and even social science also. Now next topic is integration of concepts and skills that our children have learned into a problem solving ability. This another point also is to some extent same line, where we kind of connect with children's own knowledge and like varied form of knowledge and skills. We should not fixated with one particular concept. Like if I'm suppose if I'm teaching geometry, then I am fixated with geometry, but we need to integrate maybe with geometry with the sense of measurement, measuring the earth, measuring some given area, and also with some social problems which are related to social sciences and sciences also. So all these things we need to consciously do while we are doing mathematical modeling. So all these points won't be possible to do if we restrict ourselves to the curricular objectives. We need to broaden our perspective to bring to like bringing all these meaningful context for the learner. So now we'll move towards the next part, that analyzing and constructing the processes involved in mathematical reasoning. Mathematical reasoning is the critical skill that enables a student to make use of all other mathematical skills. With the developing of mathematical reasoning, students recognize that mathematics makes sense and can be understood. They learn how to evaluate situations, select problem solving strategies, draw logical conclusions, develop and describe solution, and recognize how those solutions can be applied. And the last one, which again establishing linkages between mathematics and daily life experiences and across the curriculum, which again is very important point for doing mathematical modeling, which I already said that mathematical modeling, the important aspects of modeling is when we connect it with some real life situations. Now we'll move towards the next part is the difference between conventional and that mathematical modeling. In conventional model method, we learn the facts, we follow some procedures, we learn some definitions and theorems, we just practice the proof of the theorems, and it is a very result and solution oriented method. And but when we are doing mathematical modeling aspects, we collect the data from the scratch, we follow some constructivities, or we can call it as a constructionalist. When we are doing a digital platform, when we are doing something in digital platform where children construct their own mathematical knowledge, they construct their own definition, they construct their own understanding. Once they have kind of constructed, they evaluate it, they establish it to give an observation or data. Collecting data is the same as observation. We can observe some phenomena, we can also kind of quantify those observations and collect data in terms. Once when we evaluate and establish, we will generalize, we also find some patterns like chart, graph presentation, graphical presentation. We also kind of use an algebraic equations, and based on that we can predict what will be the future result. We can also infer the situations in a more meaningful, more better way or deeper way that just seeing the result. Once we predict, once we understand, once we do all these activities which are listed, we understand some phenomena in more deeper way. So now I will give one example I've taken from our NCERT textbook only. So how we can use uh, the data to represent, to analyze. Suppose the given wages of 30 workers in a factory is given, and now my question is that how do we represent the data? Anyone please, how do you represent this data? 30 numbers are given.
by making groups.
Using tally marks.
Okay.
Tally marks.
Okay. Using, very good, madam. Using tally marks, we can construct a frequency distribution table. Any other?
So first we have to group the data. Grouping of data,
Okay,
I
fine,
think
sir.
it is necessary.
Okay, fine. Grouped frequency distribution table by using tally mark. Any other? Any other for we can represent the data?
Histogram, frequency, polygon.
Okay. Okay. Very good, madam.
Histogram, polygon,
We can
And
represent
and
the
bar
data in
chart.
histogram, polygon,
Pie
frequency
chart.
polygon, pie chart. Very good.
chart.
Other than representation, any other way to represent this data? I have not given that what we have to do. Fine.
Pictogram.
Yes, sir.
Pictogram. Pictogram.
Pictograph. Okay, fine. We can form the frequency distribution table. Then we can represent the by using pictograph. Any other than representation part, another other than pictorial part. What we can do with this data?
So tally.
That part is already over, madam. Constructing frequency, grouped frequency distribution table by using tally mark. My question is that what we can do with this 30 data, 30 numbers.
We can calculate the total wages per week.
Okay, fine,
Okay.
madam. Very
And the
good. We can find
mean
the
wages.
total wages of
So
the
we
30
can
members.
compare the wages of people.
Mean mode.
Very good, sir.
We can mean
That
mode.
part I want.
Mean mode,
Measures of
median.
central tendency. Yes, we can arrange the data in increasing order or decreasing order. We can find the median also. We can calculate the median also. We can calculate the mode also. So like that, we can use this data uh, to for student also. Let the student think, and student will represent the data in a number of ways. So I took only one way, that you have already told, that group frequency using tally marks, and I have represented in histogram. Okay, so now we'll move toward the next section, that is the digital models. How digital models we can use in nowadays. This is very important part, because we are all are busy in online teaching, and digital modeling is the process of creating a computer model of an object that exactly replicates the form of the object. So now I'm going to show some digital models. I think you have already seen in the previous sessions, because all are doing this one only. So this is one of the digital model, mathlearningcenter.org. So many apps are there. We can use it for mathematical modeling. So I will demonstrate one. So this is the website. I will share this link to everyone through WhatsApp, mathlearningcenter.org. So, so many apps are there. You can go through all the apps. So, I'm going to demonstrate the first one is that is GeoBoard. Even you can use GeoGebra also, RoboCompass also, but you have to connect it with real life situation. Then only it will become a mathematical modeling. Okay, fine. So we have to click on Open Web Source. Then there are three different types of geoboard is available here. One is square form, another is rectangular form, and the last one is circular form. So I'm going to demonstrate the one rectangular form, how we can use this in real life situation. For example, uh, one tower is given. Okay, one tower is given. The height of the tower is suppose h. Okay, and we are observing from here, somewhere here point, we are observing the top of the tower. Some angle of elevation we are getting. Okay, here angle of elevation. Now if we move towards the tower, then what will happen? Suppose this is the angle of elevation now present at present point. Now we are moving towards the tower. So what is happening? The angle of elevation is increasing. Okay, so in this way we can use this model to explain the angle of elevation. Even angle of depression also we can explain. Okay, so this is the one of the digital model, and even you can use this digital model to explain the different shapes also. For example, I'm going to draw one simple square. So like that you can take up the different types of shapes. Even we can use it for similar triangles, some activities also. Okay, so now we'll move towards the another online app is Maths is Fun, that you have already done. I think you have already used this one. So I will show you one in this algebra. I think algebra also might be you have done in the previous sessions. Suppose one equation, this can be used to solve by using solving the linear equation in one variable. So how this can be done by using activity method. Suppose 2x plus 2 is equals to x plus 6 is given equation, and what we will do, by how to solve, we will make it the variable at one side and the constant at the other side. So I want x on this side. So what I will do, I will click on minus x, so it will subtract my x from both sides. So variable is balanced. Now I want to balance the constant. So I will remove this 2 by subtracting 1. Okay, now the problem is solved. And if you want to take another equation, you have to click here, new equation. Another equation will come up. In this, one more very interesting app is there, data app. Okay, that I will show by using this example. The given below are the seats won by different political parties in the polling outcome of a state assembly election. Political party, 6 parties are given: A, B, C, D, E, and F, and the seats won is given as 75, 55, 37, 29, 10, 37. Now, actually, this is the question I have taken from textbook, but while mathematical modeling, what you have to do, you can collect the data. So you can collect the data from internet for any election, or like COVID-19, a number of cases are there for this, for the month December. Like any data you can take and you can represent, you can generalize, you can make it in the form of graph. So I'm going to represent in bar graph by using, see, this is the first page. We have to click on data and we have to click on graphs index. Then here make a graph is given, so we have to click here. Okay, so already whatever you do in the previous, that will appear here first. Actually I did yesterday, so some data was there. So political result, I want to give title as political result. Okay, political result, and x-axis is political party. So political party will come over here, and the y-axis is seats won. So it will come up here. Now the values are given. So we have to write all the values by separating it by comma. 75, second 55, then 37, then 29, then 10, and the last one is 37. So our graph is almost over, but labels are blank, so we have to write the corresponding labels by typing. The first one is A, comma, B, comma, C, comma, D, E, F. So our bar graph is over. So like that we can collect the bar any data from the real life situation, and we can represent it in the form of graph. And here another line graph is also there. The same data we can check it with the line and dot and pie chart also. Okay, histogram will not work because this is not in the form of class interval. So like that you can represent your situation in the form of bar graph. Okay, so now we'll move towards the another section, the turtle logo games simulations. In this way also we can teach the students some modeling. So I will demonstrate one by one. So let us move towards the first one, the turtle logo and the turtle blocks. This is the platform, Clicks platform. So many apps are available in this platform. I will share this link also. This is the platform, and when we click on turtle block, uh, this picture will come up. Okay, I will demonstrate this one also. This is the turtle. We can move anywhere by using mouse, and this is a free version. Only 3 movements are there: forward, left, right. So we have to drag one by one. Okay, and suppose I want to draw a square. I want to draw a square. So what I have to do, I have to draw a line first. So I want to make this turtle 2 times forward. So 100, 100, 200 is over. Now here I want to make the turtle to move to turn 90 degree. So here the right turn is there, will enter 90, then we'll click on right. So turtle will move right by right and by 90 degree towards right side. Again we can move, we have to click 2 times forward, so that because in squares all 4 sides are equal. Again 90 degree, again 2 times forward, again 90 degree, 2 times forward. So our square is completed. Like that we can give any task to the student, that we can draw even equilateral triangle, right triangle, rectangle, any shapes we can draw using this turtle block game. And the next one is there, police squad game. This is also one of the platform where we can teach the students to identify the for different types of polygons. So this also I will going to give one demo. See, this is the first page. In this game, we have to some clues will be there with respect to straight lines, and we have to identify the culprits. Okay, so this is the level 1. So I'm going to demonstrate only one level. So here we have to click on clue. One clue will be there, and we have to release the diagram, release the persons which are not culprit. So the clue is the culprit has at least 3 straight sides. So which one you want to release? Please identify. At least means greater than or equals to 3.
Fourth one, sir.
This one?
Fourth one, sir.
Okay, fine. So we have to click on this and we have to release. So if the answer is correct, then the clue will appear once again, and otherwise if we click on the wrong, then our token will be lost. So again we have to click on clue. The culprit has less than 2 equal pairs of sides. Less than 2 equal pairs.
Second one.
Which one you want to release?
Second one.
Second.
Sure.
Second one, sir.
So we will release third.
Okay, we will release third. Correct. Correct or wrong? Token lost. Why this is wrong?
Sir, because that is a rectangle, it is having 2 pairs of.
Yes.
Okay, so
It is a
let's start once
rectangle.
again. Let's start once again. The culprit has at least 3 straight sides.
The third one.
Third one, okay. Now the next step. The culprit has less than 2 equal pairs of sides.
Fourth. Last one. Fourth one.
This one?
Fourth one.
Okay, fine. Again wrong. Why? Less than 2 equal pairs of sides. So this may be the culprit, Anna?
Yes, sir. That is
Okay, okay, fine. Again, the culprit has no curved sides. Which one you want to release?
second one.
Second one, sir. Second one.
The culprit has no curved sides. Okay. Next clue. The culprit has less than 2 equal pairs of sides.
Third one.
How many equal pairs are there in third one?
So it's not possible to say.
No equal percent.
Okay. Now it is visible.
First or fourth we can release.
One pair, sir.
First or fourth.
Okay. Sir told 4 to release. Again token lost. Okay, because of shortage of time, let us move towards the next part. I'm going to close this one. Okay, when the culprit successfully you caught, then one fabulous work done, like that some message will come up. Now next I'm moving towards simulation part. Now PHET interactive simulation, this also you have done, I think Purushottam sir have taken up this one. So in this also I'm going to demonstrate one small uh, demo of area building. Okay, so when you click on this area building here, so this will come up. I'm going to play one game here. So I'm going to play the sixth one. Using this game, you can teach the students uh, how to use area, perimeter, fraction all together. Sir, please mute your mic. Okay, so the area is given 15 and the perimeter is given 16. And the light shaded fraction is 2 by 3 and the dark shaded the fraction is 1 by 3. So 2 by 3 means how many blocks we have to use? 2 by 3 of 15, 10, and 1 by 3 of 15 is 5. So dark one we will use 5 and the light one we will use 10. Now we'll check out the combination of 15. How many combinations are possible or dimensions? 15 by 1, one dimension, and another
3
is
fives are 15. 3 fives,
yes,
3
another
times 5.
dimension is 3 by 5, and we will check which dimension is fulfill our this condition. Perimeter is equals to 16. The first the 3 into 5 dimension.
Right.
Okay, so
3 to
right, we'll start with 3 into 5. So 1, 2, so total 5. The light should be 10 and the dark should be 3. Okay, now our block is completed. Then we have to click on check. If answer is correct, one smiley face will come. If answer is wrong, then sad face. So this is correct. So I will make one answer wrong by simply putting. Okay, so now in one of the region, one participant asked me that, sir, how we can use this for slow learners. So for that also this is very useful. We can start with level number 1. Only area, the student has to construct block such that the area should be equals to 9. So he can use any one combination, or he can use any shape. He will be happy to see the smiley face. So like that, if that particular student is drilling in level number 1, again level number 2 is area and perimeter. Now the one step you can take up for the slow learner. Okay, so this is the example of this simulation. Now we'll move towards the next one, is the pedagogical model. Already I told you that the pedagogical models are those models which teachers sometimes provides to students so that they better understand some mathematical concepts, like the division of integer models. If we use this model, the child will understand this concept, integer mol, 3D shapes. So many models. This we are using in our teaching also. So the pedagogical model describes what effective teachers do in their classrooms to engage students in intellectually challenging work. It provides an overview of the learning cycle, and it breaks up into 5 domains or phases of instruction, which I already told you that I will discuss in the next section. These are the 5 domains. The first one is engage. The teachers know their students well and engage them in building supportive, inclusive, and stimulating learning environments. Teachers motivate and empower students to manage their own learning and develop agency. The next one is explore. Teachers present challenging tasks to support students in generating and investigating questions, gathering relevant information, and developing ideas. They help students expand their perspectives and preconceptions, understand learning tasks, and prepare to navigate their own learning. The next one is explain. The teachers explicitly teach relevant knowledge, concepts, and skills in multiple ways to connect new and existing knowledge. They monitor students' progress in learning and provide structured opportunities for practicing new skills and developing agency. The fourth one is elaborate. Teachers challenge students to move from surface to deep learning, building student ability to transfer and generalize their learning. They support students to be reflective, questioning, and self monitoring learners. And the last one is evaluate. Teachers use multiple forms of assessment and feedback to help students improve their learning and develop agency. They monitor student progress and analyze data to draw conclusions about the effectiveness of their teaching practices, identify areas for improvement, and address students' individual needs. So these are the 5 domains of pedagogical model. Now we are moving toward the next section, the individual work for the participants. What you have to do today, you have to identify a real life problem, any real life problem, and then you have to represent in mathematical form. It may be in the observation data form, and you can, if it is in the form of data, you can represent it in the graph, chart, and whatever it be. And after that you have to list the learning outcomes. So we want every participant has to complete this task, and after that they have to list the learning outcomes. Now the next is group work for participants. So in the evening session, every group has to present these two tasks. This is the individual task. You can select one best one. This is nothing but this is the individual task. While group discussion, you can select the best one to represent in the evening session. And this one is the group work which you have to do together. You have to identify a math topic, then model it in real world context, use any digital model to solve, then you have to list the learning outcomes. So this is the group work for all the participants, and one individual best individual work, and another this you have to make only one, not more than two, more than one. So I will show one more example. Let me discuss about that simple interest problem which sir explained. Simple interest problem, if suppose I will explain the student by taking p r t, okay, the value of p, principal, and rate of interest and the time period, and simply I'm taking that formula and substituting the value to get the interest. So that is not mathematical modeling. So what we have to do, we have to create some real life situation. We have to create the real life situation. In that real life situation, we have to do the mathematical modeling by following the process, okay, which sir have shown. I will show one more example, uh, the height and distance example, the height of tower, which you have already did in class 10. So how that question can be done by using that the mathematical modeling process. So this is the question: the angle of elevation of top of a tower from a point O on the ground, which is 450 meter away from the foot of a tower, is 45 degrees. So angle of elevation is given 45 degree. Okay. So what is the first step? That we have to understand the problem. Okay. So let h be the height, and we will draw one rough diagram. It is given that the horizontal distance of the foot of a tower from this point is 450 meter on the ground. Okay, so that means here we will take this distance as d, this horizontal distance, that is 450 meter, and we also know the angle of elevation, that is 45 degree, this one, and we will denote it as theta. Now we have to identify that what is given and what we have to find. Okay, so the real problem is to find the height of the tower using the known distance, that is d is given and the angle of elevation is given, this is theta. Okay, so now the next step is mathematical description and formulation. So how we will describe mathematically? The three quantities mentioned in the problem is height, distance and the angle of elevation, that is 45 degree. Distance is 450. So how we connect these three which with each other? We will take AB. We have already drawn the diagram. AB we took as tower, and OA horizontal distance, that is from the point O to foot of the tower, and angle AOB is the angle of elevation, that is 45 degree. Then if we use the tangent, okay, so you can ask the student that I'm going to draw one rough diagram here. So this is theta, we took this as theta, and this is D and this is H. So with this, with respect to this angle, this is opposite side and this is adjacent side. So which trigonometric ratio is connected with this one? That is tan theta. So tan theta is equals to H by D. So from that we will get H is equals to D tan theta. Let it be equation number 1. Now the value of D is also given, that is 450, and theta is also given 45 degree. Now the next, this is the equation connecting with these three quantities, that is height, distance and angle. So next step is solving the mathematical problem. So we use this equation to solve to find the value of height of the tower. So we'll substitute theta is equals to 45 degree and D is equals to 450 meter. H is equals to tan 45 degree into 450. So tan 45 value we know, that is equals to 1. So we'll substitute 1 into 450, that is 450 meter. So the last is interpreting the solution. We got the height of the tower is 450 meter here. So I want to tell you that the problem is very simple, but how this problem we can go through the process of mathematical modeling. So we have to follow these steps. In the step number 1, we have studied the real problem. We understand the real problem and found that the problem involves three parameters: height, distance and angle of elevation. Okay, that means in this step we have studied the real life problems and identify the parameters. And in step number 2, we use some geometry and found the problem can be represented geometrically as I have shown in that figure. Then we use the trigonometric ratios for the tangent function and found the relation as H is equals to D tan theta. And so in this step we formulated the problem mathematically. That means we found an equation representing the real problem. And in the step number 3 we solved the mathematical problem and we got the value of H is equals to 450 meter. That is, we found the solution of the problem. And in step number 4, that is the last step, we interpreted the solution of the problem and stated that the height of the tower is 450 meter. We call this as the interpreting the mathematical solution to the real situation. I hope this example is clear. And one more step is there, the fourth step, that is validating. So for validating, we'll go through again step number 1 and we'll check that whether whatever the solution we are getting, that is valid or not. If that is not valid, again we'll start with the step number 1. That is not means this question is valid, so that is why I have not taken that step number last step. I hope this example is clear to all of you.
Pragmatic and learning outcomes. That is very, very important to this. Okay.
Let me clarify once again. Every group has to present one this work, and this is the individual work actually. In your group work, you can discuss every participant's individual work, and the best one you can present in the group work. This is nothing but this is the individual work, the same thing. So this is to be done by every participant, and I will give one link of Google form in which you have to upload your individual work, and even if you can upload your group work also. And group work is one for each group. How many groups are there? How many groups are there?
5.
5 groups. So five mathematical modeling will be presented on this one, and 5 best individual work from each group will be presented in the evening session. Okay. So any doubt in this group work or individual work? I will share the PowerPoint presentation in the WhatsApp group, and even all the links, whatever I have shown, everything I will share in the WhatsApp group.
Excuse me, sir.
Yes, sir.
You have shown the group work on the top. Those topic only. Now, we have to make each participant make to one among that the real life modeling.
Yes, sir.
Isn't it?
Yes, sir.
And give to discuss with our group. Then we will present one in the evening.
Yes, you have to present the best one.
Okay.
So I am going to share this Google form.
When we have to submit the Google form, sir?
Google form, sir, before discussion also you can submit, na? Before
Yes. That is what will be. Any particular, because now only we are going to start
this
before
link,
evening.
Sir, this link
We will submit.
this link will be open till night, and
Okay.
after collecting all the individual work, I will share this to the course director, and then course director will compile and send it to all of you. So here you have to upload. Okay, and the format will be document, that is Word file, presentation, PPT, PDF, and if you wish you can make a small video, but it should not be more than 10 MB, so that you can do it and you can upload in this form. I will share this in the WhatsApp group, and if you have any doubt with respect to this work, how to do steps, all those things, you can go through once again the PowerPoint which I will share in the WhatsApp group. I will share also the PowerPoint which we have received in our master trainer program. That also PowerPoint I will receive. If you wish, you can go through that also. Okay, sir. I'm going to stop my presentation. Still, if you have any doubt, let us know.